So again, a matrix is a rectangular array of real numbers. And when we talk about the order of a matrix, I'm talking about the size. How big is it? And when we name the size of a matrix, we name it by the number of rows and then the number of columns. And we write it like this, M by N. Rows is M. N is my columns. Which way do rows go? They go horizontal, right? So if I'm looking at matrix A, okay, you'll notice the capital letters in front of them. Those are the names of the matrices. How many rows do I have? 2, okay? And then we write it by the number of columns. Columns are vertical. How many columns do I have? 3. So matrix A, the order of matrix A, that will be a question on your test. I'm going to ask you, what is the order of it? That's the size. How big is it? Rows by columns. So matrix A is a 2 by 3. Everybody okay with that? All right. So what about matrix B? If I'm looking at the number of rows, how many rows do I have for B? 3, right? 1, 2, 3. And then how many columns do I have? Just 1. So matrix B is a 3 by 1. And then C, you see down there it says a square matrix. Why do you think it's called a square matrix? Because it's equal. The number of rows and the number of columns are equal. So we have 2 rows and we have 2 columns. So you can call it a 2 by 2. Also, sometimes people just write 2. So if they're talking about the order, if it's a square matrix, you can just write the number 1 time, okay? I usually just go ahead and write a 2 by 2 because we'll need to do that in a couple of days when we do our multiplying, which is tomorrow. But anyway. So that's the first thing we're going to talk about. Then the other thing that I don't have written the word, but I need you to know what I'm talking about. Each number inside of a matrix is called an element. So when I talk about an element, that's what I'm talking about, the individual number, the individual entry in our matrix. So far, so good? Okay. Now, and again, they are just, the order is written. I just didn't want to show it to you first because we wanted to talk about how to find it. And then another thing that they will do is, like this piece down here, they will put the capital letter, that's which matrix they're talking about, and then they'll put a subscript of its order, okay? So I may tell you to add this matrix to this matrix, and it'll give you the order, and so then you have to, once we talk about how to add, you'll have to verify from there, okay? So that's just saying that matrix A is a 2 by 3. And they've got matrix B being a 3 by 1, and matrix C a 2 by 2 or just a 2, okay? Is everybody okay with those? Okay. Then we have a 0. All right, so a 0 matrix is a matrix where basically all of your elements are 0. And the symbol that I'm referring to is this one right here. It's got a 0 with the bar over it. That lets you know it's a 0 matrix. And here they're telling me that A is a 0 matrix that is 3 by 2. And you'll notice that the example they gave you is 3 rows and 2 columns. So what I would probably do on the test is give you something like this. Okay, give you that symbol with the subscript. What that means is you have to write the matrix that fits that description. Well, because it's a 0 matrix, because of that symbol, we would draw a matrix with 4 rows of zeros and 2 columns. Okay, so you'll have a question very similar to that. You just need to know what the symbol means, and then the order is how many rows versus how many columns. Everybody okay with that? Uh-oh. Okay, first of all, what size is matrix A? What's the order of it? 2 by 3. And what's the order of matrix B? 1 by 3. Okay, 1 row, 3 columns, just to get practice on that, because again, we will have questions like that on the test. So when it says find and it has a lowercase letter and 2 subscript numbers, it's asking you to find the element in that matrix. Okay, so in this one, we're talking about matrix A. The first number is which row it's in. Okay, so this 2 is referring to row 2. This 3 is referring to column 3. So if I look at row 2, column 3, what number is in that position? What element is there? 1. That's what you're finding. Okay, the little letter tells you which matrix we're looking at. And then the subscript, the first number is which row you want to look at. The second number is which column you want to look at. And you're just telling me what value or what number is in that position. Okay, so for number 2, it's matrix A again. But this time, which row am I looking at? Row 1. And then what column am I looking at? 3. So what number is in row 1, column 3? 2. I'm going to explain in just a second. Everybody good with that? All right, number 3, still matrix A, but what row are they looking for this time? 3. Do I have a row 3 in matrix A? No. So this one is not possible. I can't find an element in row 3 because there is no 3. So I'm just going to put NP for not possible. Okay, and again, this little paragraph you do not have to write down, but I'm going to talk to you about it. When they're talking about a comma, they're talking about between these two numbers, okay? So sometimes in some books, and whoever writes tests or whatever, some people write it differently. What they're saying is I could write the same thing, the A, and I could put a comma in between the two. So you'll see that it means exactly the same thing, okay? It doesn't change. It's just some people put a comma in, some people don't. The only time you would have to have a comma is if you have your number of rows or number of columns is more than 1 digit. So like if you had 10 rows, you would have to put 10 and then a comma in whatever your column is, okay? But other than that, you don't have to put a comma, but you can. Now I'm going to write B again just because I need it to be right here. I want you to do these 3. They are referring to matrix B, so I just rewrote it. And again, I just changed it up a little bit, putting some commas in between it because it depends on who the author is of whatever test or book you're looking at, on whether they're going to put commas or not. But we're still looking for which element is in the position that they are describing. What row, what column, what number is there. If you don't have that row or don't have that column, then you just put not possible because we can't do that if there's not enough rows. All right, which element is in matrix B, row 1, column 3? -1, okay. Which element is in matrix B, row 1, column 1? 5, okay. And then which element is in matrix B, row 2, column 1? Not possible. There isn't a row 2, so I cannot find it. I feel like this is about to cut out. It's working okay. Is everybody okay with that? All right. Next. You have 2 new matrices, and what we're going to do is find the additive inverse of them. I'm going to give you a minute to write those down. We're going to find the additive inverse. Matrix A, row 1 is 4 and 6. Row 2 is -2 and 3. Matrix B, row 1 is 0. Row 2 is 4. Row 3 is -6. We are finding the additive inverse, and the symbol for that is just a negative sign in front of whichever matrix we're talking about. So if I think about the number 3, what's the additive inverse for 3? -3. It's basically just changing the sign of everything, multiplying everything by -1. It's just the opposite value. So if I wanted to find the additive inverse of matrix B, my first row in my matrix is a +4 and a +6. So what would those be? -4 and -6. You're literally changing the signs of the numbers. My second row is a -2 and a +3. What would that turn to? positive 2, negative 3. That is the additive inverse of A. So take a minute and do the same thing for B. If I'm doing the additive inverse of B, does 0 ever change? No, it's not positive or negative, so it just stays 0. And then what's that 4 going to become? Negative 4, and then the negative 6 is going to become 6. Okay, that's all you're doing is you basically change the sign of every number. That's the additive inverse. Multiply everything by negative 1. Easy enough? Okay, we're going to add and subtract now, and then we'll talk about the second part of what we're doing today. Again, super, super easy. I want you to take a minute and write down those 4 matrices, and then all right, so for the one and only rule for adding and subtracting matrices is that the matrices must be the same size to add and subtract. Okay, meaning they have to have exactly the same number of rows and exactly the same number of columns in order to add and subtract. If they do not have the same number of rows and the same number of columns, you cannot add or subtract them, so you just put not possible. Is everybody okay? Okay, so let's take a look at one. We're going to add A and B. First, check. Are A and B the same size? Yes. So here's how it goes. Okay, I'm not going to rewrite them because I don't really have a lot of space, but we take each element in the same position in the matrices and we add them together. So for example, whoops, that's not what I wanted to do. I'm going to take the first element in both matrices and I add those together. And that goes row 1, column 1 in the answer. And I just do exactly the same thing for every element. I add 2 plus 0, and that goes there. I add 6 plus negative 2. Do you see how it's working? And then we do exactly the same thing on the second row. We're going to add negative 2 and positive 1 together, which gives me negative 1. Then we're going to add 0 and 5 together, which gives me 5. And then we're going to add 1, whoops, we're going to add 1 and negative 7. And that is the result of A plus B. You literally add the numbers that are in the same position. Does that make sense? Okay, go ahead and try 2 and 3. Again, they have to be exactly the same size in order to add or subtract. Right now we're just adding. We will subtract in just a second. The good news is with matrices, because a lot of the times they are big and they have multiple numbers, if you miss one number, you're not getting the whole problem wrong. You'll just lose a point or two, depending on how many you miss in the matrix. So there's a lot of room for partial credit. Can I do 2? Can I add C and D together? Yeah, they're the same size. So what do I get? What's my first row going to be? 9 and 0. And then my second row? Negative 6 and negative 5. And that is the answer to C plus D. What about A plus C? Can I do that one? No, they're not the same size, so we're just going to put NP for not possible. You can write it out if you want to. Okay. Now we're going to do the same thing, but we're going to subtract, which is essentially the same, except for you subtract the 2 numbers instead of adding them. These are the same for, oh, just kidding. I can't see them. You have the matrices written on your paper, right? Okay, so go ahead and do 4, 5, and 6. You do exactly the same thing, except for you do the first element minus the first element. Instead of adding, you subtract the numbers. Again, they have to be exactly the same size in order to do that. If they are not the same size, then we just put not possible. Can we do C minus D? Yeah. All right, so let's see. 4 minus 5 gives me -1. Okay, we're doing this. Just 4 minus 5. And then 0 minus 0 gives me 0. And -8 minus 2, what does that give me? -8 minus 2? -10. And then I'm going to do 1 minus a -6, which turns to 7. And so that's the result of C minus D. Can I do A minus B? Yes. Okay, same thing. We're going to go through each element. Sorry, just make some more room. It's too cluttered up there. All right, so 4 minus 3 is 1. 2 minus 0 is 2. 6 minus a -2 is 8. -2 minus 1 is -3. 0 minus 5 is -5. 1 minus a -7 is also 8. Did we get 1, 2, 8, and then -3, -5, and 8? Okay. And then what about 6? B minus C, can I do that one? No, they are not the same size, so we just put not possible. That's about as hard as adding and subtracting gets. Is everybody good? All right. Now we're going to go to the second day, which is what I had planned, but we didn't have time for that. And they're two things that are easy. Are those the same or are they different than the ones that we just used? I can't remember. They're different. Okay. So write these 2 down, or 2. Write these 4 down. My bad. We're going to use these 4 for the rest of our examples. So we have what we're going to talk about now is what we call scalar multiplication. A question that's going to be on your test is going to ask you what this 4 is called. Any number that's being multiplied by a matrix. It is called a scalar. Okay, that will be on your test. And this is even easier than adding and subtracting. What do you think a 4 in front of A means? You multiply everything in A by 4. You don't have to write it all out like I am. I'm just kind of showing you my work for the first one. But it's just literally taking and distributing that 4 to every element to rewrite a new matrix, which gives me 16, 8, 0, -4, 12, -8. So go ahead and do 2 and 3 for me. Number 2 wants you to multiply C by 6. Number 3 wants you to multiply D by -4. There are no rules for scalar multiplication. You simply multiply. What is row 1 going to look like if I multiply C by 6? 24 and 0. And row 2? 12 and 6. And then number 3, for multiplying D times -4, what's row 1 going to be? -20 and -8. And row 2? 4 and 0. Is everybody good with those? Bless you. All right, the last 2 examples. It's the same 4 matrices, so you do not have to rewrite them. But it's going to combine some scalar multiplication with addition and subtraction. So all right, with 4, first of all, with these, if I can add them, I'm going to do that first because it seems a little less work to me. But again, you could multiply C by 3, multiply D by 3, and then add. Can I actually add C and D together? Yes, they are the same size. So I'm going to keep that 3 in the front first. I'm going to go ahead and add C and D together. That's going to give me 9, 2, 1, and 1. And then I just multiply each one of those elements by 3, which gives me 27, 6, 3, and 3. that make sense to everybody? And with 5, can I add A and C together? No, they are not the same size. So what I am going to have to do is multiply 4 by A and multiply 4 by C, and then I just leave my answer as 2 matrices that are being added together because I can't actually go any further. So for A, it's going to turn into 16, 8, 0, -4, 12, -8. And then for C, it's going to be 16, 0, 8, and 4. And again, because they are not the same size, I cannot go any further. I just don't write not possible because I can actually multiply them. I just can't go any further past that.